Good evening, our dear audience. Today we are on our second lecture of circular motion. So let's start. So what we are going to cover today? First we'll learn how to visualize circular motion and we'll visualize it. How we'll visualize? Let us start. So imagine there is an object here and it has a velocity in this direction. So this is the direction for velocity. And a force is acting upon this object neither parallel nor perpendicular to the velocity. So it is in a direction like this. Okay. So if it makes an angle theta with the velocity, then we can say that it can be further broken into two components. So let's write those components. The first component will be f cos theta, which is along the direction of velocity, and the second component will be perpendicular to the velocity, which will be f sin theta. So now if we try to imagine this motion, we see that this velocity and f cos theta together gives a movement toward this direction, and this f sin theta, which is responsible for changing direction, slightly bends and bends and bends. So what the motion becomes? It becomes like this. So we can see it is a kind of circular motion, pretty circular motion. Okay, so if we now see that this f sin theta is towards the center, so we say this is as the radial force or the centripetal force. It is commonly known as centripetal force as it is acting towards the center. And what is this? As this is a tangent to velocity, and no, or as it is tangent to this circle's point, this point, so this is known as tangential force or force acting towards tangential direction. So in Newton's law of motion, we have studied that whenever there is a force, there is an acceleration. So acceleration at this direction is acceleration tangential, which is equal to a cos theta. Okay, so tangential acceleration is acting in this direction, and the acceleration which is acting in the direction of center is acceleration centripetal. Okay, so this is the acceleration centripetal, acceleration tangential, this is the centripetal force, tangential force, and the velocity. So now few of our audience will say that what if the velocity is in this direction and a force is acting on this direction. So from the vertical it is making an angle of theta. So in this case again we are going to take two components of this force vector. The first component is f sin theta, which is the centripetal force, and the second component becomes f cos theta, which is our tangential force. Okay, so in this case the circular motion is like this. Like this it becomes same way it becomes, but the only difference is this, as the f cos theta or this component of force is acting anti-parallel to the velocity, therefore the speed of the circular motion will decrease. Okay, so this is the example of non-uniform circular motion. Right, this is the example of non-uniform circular motion. So what we can say from this, that there is always, when a circular motion is happening, always there is a component which acts towards the center, that is our f sine theta. Therefore we can say that in every circular motion one thing is common, that is always there will be a force which will be acting on this along the center. So this is the centripetal force. So the centripetal force is always going to act, and there is always going to be a velocity of the circular motion. But it depends on various cases that whether this tangential force is going to act or not. Okay, because this tangential force always acts whenever there is an non-uniform circular motion. Okay, so we can also recall from this, and we can also say that the F cos theta, which is the force tangential, acts, where it acts, it acts on a tangent of a point. So it is tangent of a point on the point we want to say, but what is its function? Its main function is to change the speed. So when we are saying change the speed, we can say that it can change its speed in two different ways. Firstly, it can increase, and secondly it will decrease. So how it will increase its speed? It will increase when the velocity and this force is parallel, and whenever it will decrease, we will say that velocity is anti-parallel or in the opposite direction to the force. Okay, you are clear with this? So this is the function of. Also we can say that in uniform motion, where the magnitude of velocity, that is speed, is always constant, at that time what will happen? The magnitude is constant but direction is changing. So as the magnitude is constant, therefore there is no force acting or there is no acceleration. So we can say like this. So we are done with our visualization of circular motion. Okay, so now I am going to tell you something which will be helping us understanding the centripetal force. Okay, so what is that? Let us recall what we did in our NLM and kinematics. So let's assume a block of mass m. Okay, and let's say that a F1 force is acting in this direction and a F2 force is acting in the opposite direction, and this block has an acceleration in this direction. Okay, so as this is ground on which the object is lying, so this mass will exert a force mg, and also a force normal in the upward direction. So here, as we know that the block is going to move either here or here, it is not moving upward or downward, it is staying here only. So there is no movement in the y direction. Okay, so we can say that it is equilibrium in the y direction. So we'll say normal is equal to mg. Okay, so both this force will cut down and they will balance each other. So normal is equal to mg. Now let us remove it because it is of no use. So what we can say from here, what we can say? We can say that F1 minus F2 is equal to mass into acceleration, right? We can say this. So now their question arises that what is this mass into acceleration? Is it acting here, ma, something like that? No, it is not. So what it is? My question here is what this ma describes us. So we studied that this ma is the net force or force net, or we can say in better language the resultant force. So this ma is not F1 nor it is F2 nor it is acting anywhere in this. It is not acting in the system. Okay, so this is the value of resultant force which we have studied. This is the net force which is acting in this. Okay, net force. We are talking about net force. It is the net value of net force. It is not acting anywhere in the system. So similarly, while there is a circular motion, if there is a circular motion, suppose a block is here and it is connected with a string, okay, and the block has mass, let's suppose m. It is moving like this. It is moving like this. Okay, let us say it has velocity in this direction. So what we can say from this, we will say that if we make the FBD or free body diagram for this case, mg is acting downward. There is a tension force which is acting in the direction of center. So what we can say from this? What we can say is tension is equal to, what this tension is equal to? Tension is mv square by r. Okay, why tension is equal to mv square by r? Because we know that acceleration centripetal is v square by r. This is acceleration. So here tension is a force, right? It is a force which is acting here. And we know, and here in this direction, specific to this direction, this is the force which is acting. So if only one force is acting, we say that that force is only the resultant force. So here tension is the resultant force. So tension is equal to mass into acceleration according to Newton's law of motion. But as it is acting towards the center, so acceleration's centripetal. Agree? So tension is equal to mass into value of acceleration centripetal, that is equal to v square by r. Now if you will argue that no, centripetal acceleration is equal to r omega square. Yes, it is. But when we have to apply that? We have to apply that when we are given omega. Here we have given the velocity. So we are applying this. Yes, it is. There is no mistake to apply it. So we can also write it is equal to mr omega square. But make sure and remember that we have to only apply when we are given the value of omega. And when we are having the velocity value, we will apply this. Okay, so very simple. Now you will say that what is the mg doing, or what it will do. So here, as we have learned previously, as we have visualized circular motion, so we can understand this mg is constantly, not constantly, this mg is increasing the speed of the circular motion because it is parallel or along the velocity. So it is increasing the speed continuously. So here mg is also equal to mass into acceleration. Mass into acceleration. But what acceleration? Acceleration tangential. Okay, because in this direction the tangential acceleration is acting upon. So in this direction what acceleration is acting? Acceleration centripetal, and in this direction tangential acceleration is acting. So this is all about circular motion. And this force that is acting towards the center, or that is acting along the centripetal acceleration, this force is only our tangential acceleration. Okay, we are clear with this? So if we are clear with this, we can move to our next topic, that is how to write equation of circular motion. I hope it is clear, right? So now we have to learn how to write equation of circular motion. Okay, so we'll learn how to write the equation of a circular motion. So for writing an equation of motion, there are many people who makes mistakes. So first we have to learn that how to write a circular motion equation, and for that what are the steps which we need to follow, because if we break it into steps it will be simple for us and it will clear our basic concepts. So first and foremost thing, we have to find the center of the circle in which the object is rotating. Okay, in which the object is rotating. Secondly, what we have to do is we have to make the free body diagram. Or we have to make the FBD of the object. Thirdly, we have to break all the forces. It may happen the force is given like in this direction, it will happen. You will see in further questions, it will happen. So what we have to do, we have to break those forces perpendicular and along the direction of center. So we have to break those forces into components. Okay, so we have to make them perpendicular with the center, and it has to be along the direction of the center. Okay, so this is clear. And fourth point is that the forces which is along the center, that the net force will be equal to m into a centripetal, which is equal to mv square by r, or which is equal to mr omega square. So these things we have to do. Okay, so now everyone would be clear with this all 3 points, but they must feel that why this third point is important. So if we break it perpendicular to the center, right, if we break those forces perpendicular to center, we will understand, or we will know that who is the force which is acting tangential in the tangential direction and which is responsible for the change in speed. So which is the force that is responsible for change in speed, and why along the direction of center? Because that force is equal to centripetal force, whose value I have written here. Okay, so this is the reason too, because if the direction of force is given like this, or it is given in some other directions which is neither perpendicular nor in the direction of center, so it would be difficult for us to calculate and to find the reasons why it is applied. Okay, so we are all done with this. So these are the most important thing which you have to remember, and I will make sure and I will recall while doing every questions. So now we are going to look into some problems which are very necessary and important for our JEE Mains and JEE Advanced exam, but we'll start from basic level. Okay, so let's start. Problems. So our first problem of the day is that this is a circle and a string is there and an object is on the string, and we are given that mass of this object is m and a velocity acting in this direction. So we are told to find the centripetal forces and the tangential force. Okay, so what is the tangential force and centripetal force? We are going to find it out. So first step is that we have to find the center. So we can say that the center is right here. Okay, now we have to make the FBT. So here only two forces are acting, that is, one is mg which is acting downwards and another is tension force. Okay, so as we are seeing that it is already, tension is already towards the center and mg is already perpendicular to the center, so we have not to apply third step and we have to directly move on towards fourth step. So here tension is towards the center, so it will be equal to mv square by r, and our mg is equal to mass into acceleration tangential. So this will be our first solution or first question. Second question is that this, now there is a spring. Okay, again it is mass m and we are told to find the elongation in the spring. So, and the velocity is in this direction. So again mg will be acting and a force which is known as the spring force, that is kx, will act in this direction. The center is in direction. So we have found the center, we have done the FBD of this object, that is mg and kx. So here kx is equal to mv square by r if the radius of the circle is given as r. Okay, so we are told to find the elongation in the spring. So x is the elongation. X is equal to mv square by r into k. So this will be our x, which is elongation in the spring. And also, if we say that kx is equal to mv square by r, if we are given the value of x, then we can easily find the value for k. Okay, we can do like this. So this is our second question. These questions were very easy. Now we are moving towards a little difficult question. So now okay, this is fixed, and let us drop this. So what will happen? It will move like this, and velocity in this direction. This, so our center is this, as it is rotating like this. Okay, so this is going to be our center, and to visualize this case, what we can do is we can simply take a rod. Okay, now we are going to drop this, and it will be like this. Okay, so we'll find that its velocity is towards this direction, and it is performing a circular motion like this. If we see, so it is performing a circular motion. Can you see? It is performing a circular motion, but we are not considering the full circular motion. We are considering a small part of it, that is this. Okay, so I hope you have visualized the case. Now let us make its FPT. So first step is to find the center. This is the center. Now we'll make the FPT of the object. So this is mg, this is the tension. Okay, now there are many people who are going to say that this tension is equal to mg, but this is wrong. This cannot be. Okay, this is wrong. This cannot be. As it is moving upward, and as it is changing its direction, not direction, as it is changing its position in y-axis, so we are not to say in this case. So we will not say that it is in equilibrium in the direction of y. It is not in equilibrium. So if it is not in equilibrium, then we can't say that tension is equal to mg. So what we'll say, that T minus mg is equal to a centripetal. Why T minus mg? Because in every circular motion, a centripetal acceleration is acting towards the center. So as acceleration is towards the center, so the force, this force will be subtracted by this force. The upper force will be subtracted by the lower force. So tension minus mg is mass into acceleration centripetal. So tension minus mg is equal to mv square by r if this distance is r. Or if we are said that it is moving like this with omega, then we'll say that tension minus mg is equal to mr omega squared. Okay, we can also say this. So from here we can find the value of tension. Tension is equal to mr omega square plus mg. Okay, so this is the value of tension. Or if you want to find the value for mg, we can also find it. Okay, I hope you're clear with this. So let us erase. Now a second type of question, okay, of similar question to question number 3 we are going to solve, that is so we are going to solve for this question. Okay, so now we are going to, first we have located the center, which is C. Now we'll make the FBD of this block. So what will be the FBD? FBD will be mg acting in this direction, tension acting in this direction. You see, now it is difficult for us to find that we are seeing that this is the center, but mg is not perpendicular to the center. So first we have to make it perpendicular with the center. Okay, so what we can do here is, here this angle is also theta. Okay, this is the mg which is acting here, and if this is theta, then this angle is also equal to theta. So now if mg is acting here, it will have two components, or it will make two components. The first component which will make is mg cos theta, which is along the velocity, and the second component which it will make is mg sin theta. So here we can see that this tension and mg sin theta are opposite to each other, and as we know that the acceleration is in this direction, that is, acceleration is towards the center. So we'll again do t minus mg sin theta, which is equal to our mv square by r, or mr omega square. So this is the value of our centripetal force. Now this thing which is the resultant of two forces, this is only our centripetal force. Okay, this is our centripetal force. And this mg cos theta, what about the mg cos theta? Again, as it is acting along the direction of our tangential acceleration, we will say that mg cos theta is equal to ma tangential. So mass gets cancelled, tangential acceleration is equal to g cos theta. Okay, from here we can find the value of tension, we can find the value of mass. If we know the angle, g is a constant, so we can find the value of mass, we can find the value of tension. We can also find the value of tangential acceleration if we are told to do so. Okay, so we can find many things from these informations. So we need to know how to write this information. These informations are only known as the equation of a circular motion. So this information we have to write, and we can find everything from it which will be given in the question and which will be told to find in that question only. So now we are going to start a new section in our problem, which is the conical pendulum. This is an important section, and in JEE Mains and Advanced, questions are asked based on this section. Okay, this is very easy, and we also need to grasp these all questions so we can understand and we can solve our questions in JEE. So what is conical pendulum? This is a wall Okay. This is a string which is attached to a bob, or you can say a mass, okay, which makes an angle theta with a vertical, and this does circular motion like this. So this does circular motion, this do a circular motion, this object. So now we are told that this length, the length of this string is L, the mass of the bob is M, and we will be told to the question will tell us to find it may say to find the centripetal force, the centripetal acceleration, and many other things it will tell us to find. Okay, so first we have to locate the center. Now many of us do a mistake that we say the center is here. This is not the center. Recall those lines. We are to find the center of the circle in which the object is doing circular motion, or object is rotating along. So we need to find that center. So object is doing circular motion in this way, and the center of the circle along which it is rotating should be this, which we say as point A for now. Okay, second step is to make the FBT, that is free body diagram. So mg is acting in this direction, tension is here. So now we will follow the third step, that is we need to make these forces in the direction of center and perpendicular to center. So we can all see already that this is the direction for center, and mg is already perpendicular, so we have to make the tension along the direction for center. Okay. Suppose the length of the radius is given as r of the circle. So this angle is theta. So if we make a line like this angle will be also equal to theta. So this is tension. This will be our T cos theta, and this will be T sin theta. Okay, let us make the diagram big. So this is T cos theta, this is T sin theta, this is the center A, mg is acting downwards, and as this force is in the direction towards the center, centripetal force is acting in this direction. Okay, and the length, the radius is given as r. So we have to write the equation of circular motion. So what we'll write? We will write T cos theta is equal to mg. Why T cos theta is equal to mg? Because this bob or this object is not changing in direction in the y-axis. Okay, it is not moving in the y-axis or y direction. It is only moving in this direction. Okay, in this plane it is particularly moving. So in the y direction we can say that it is in equilibrium. So we will write as this. Okay, now the T sin theta component, which is along the center. So a centripetal acceleration will be acting upon it, and which will be equal to mass into a centripetal. So finally what we can say, T sine theta is equal to mv square by r. Okay. Here, what is r? R is the length of the radius. So better to denote with the small r. Now, if sometimes question says, or the option, basically it is multiple choice question. So option is given with the L, with respect to L. So what we'll do in this case? As we know, if this is L and the angle theta is this, so this will be L cos theta and this will be L sin theta. So we can say R is equal to L sin theta. Therefore, we will say T sin theta is equal to mv square by L sin theta. So if we told to find the velocity, what we'll do, we are told to find the speed, we'll do TL sin square theta by m root over give us velocity. So this will be the velocity. Now we can find many other information from this thing. Now the second type of question which we want to do, which we'll see, that the same question, but the difference is in that question we were given the velocity, but here we will be given the omega. Okay, so this is L, tension T is acting, this is theta, this is mg, this is the center of the circular motion C. Okay, so this is theta, therefore this is also theta, this will be T cos theta, this component is T sin theta, and this is mg. Okay, so T sin theta is along the center, so T sin theta is equal to mr omega squared, where r is the radius of the circle. Mr omega squared. Now why omega? Because omega is given as the angular, velocity. So that's why we are taking omega, because whenever there is velocity given we use velocity, whenever there is omega given we use omega. Now as this is L, so this length will be L sin theta. So R is equal to L sin theta. We'll put this value. Now we'll get T sin theta is equal to ml sin theta omega squared. Sin theta gets cancelled. T is equal to ml omega squared. And similarly, we can also say that T cos theta is equal to mg. Okay. Now we can find many things from here. We can find the angles, we can find the tension. Already we have found the tension, so we can find the angle, we can find the mass, and many other things we can find. So this was our second question from conical pendulum. Now we are going to focus on our third question. So the third question, which says that okay, so this is given. This is the object. This is the center. this length is r, this is theta, this length is r. We are told to write the equation of circular motion. So first thing is we need to find the center. Center is at this point. Okay. Now we'll make the FBD. This becomes mg. Now in this case we are not having any string. Okay. We are given the length of this r. Okay. So we are not having any string. To show that this angle theta and this length is r, I am making dotted lines. So please don't understand that. Please don't say there is any string. There is no string in the question. So mg is acting downward, and as the object is touching this, so a normal will be acting. Okay. Now normal is always away from the body. So will like this. Like this we'll see. This is normal. Now if this is theta, then we'll again draw vertical line and we'll say that this is also angle theta. So if this is normal, it will have two components. One is here, that is n cos theta, and another towards the center, n sin theta. So again here centripetal acceleration is there. So t sin theta is equal to mr omega square, which is equal to mv square by r, and n cos theta is equal to mg. So in the previous question we got t sin theta, which was equal to mv square by r. Here we are just getting this normal we are getting. Okay. Now so you can just see that in the inner portion there is the same question which was the previous one. Okay. So this is a tendency which is shown by the JEE paper organizers or those who make the JEE papers. So they do like this only, that they make some story, make the language difficult, make the mathematics difficult. What do I mean by mathematics difficult? They make the calculation difficult, but the physics is very easy. You can see that in this place tension was there, but now in this case normal is coming. Okay. And there is outer frame, something like bowl. Okay, we say hemisphere, outer hemisphere is there. Inside this same story is happening. Nothing. And they can also say that this is the now they will add a string on. They will also add a string on. I am making the diagram, but they will use language. Okay. So in the description box I will attach some of the language problems which you can solve it. So you will have benefit. And the language problem, there are many language problems, okay, that I know the concept, I can solve the question, but I can't interpret the language. I can interpret the problem, or I can interpret the solution of the problem with the language. So that thing should be clear. So I will add some questions which are the previous year questions of JEE Mains and Advanced, so you may solve it once. So this is the center again. This will be mg. This is the tension force, and one more thing is there, that is again it is touching, so normal will be acting away from the body. Normal. Okay, normal. So normal is also acting. This is the angle theta. So in this direction what happened? There are two components. One is n cos theta, as this angle is theta, and one more is t cos theta, because there are two forces right now. So here also n sin theta and t sin theta. Okay, so we'll add this, add this. Okay, clear? So the thing is same, but we are having more forces. Number of forces is getting increased. Okay, so in this case we'll just write like this, that n cos theta plus t cos theta is equal to mg, and n sin theta plus t sin theta is equal to mr omega square. Why omega square? Because omega is given. Simple. So if we are told to find the sin theta, so we can find it by, we can take sin theta as common, mr omega square sin theta equal to mr omega square okay. Now if we are told to suppose find the omega, then what we'll do? Then we can simply write that omega is equal to n sin theta n plus t divided by mr root over. This will be the value for omega, which is coming from this equation. Okay. Also, what they can do is, they can, now what is this r? This r is the radius of the circle. But if the length of the string is L, suppose, then as this angle is theta, this is the length, this is the angle theta, this is the object. So if this angle is theta, this angle is also theta. So this component becomes L cos theta, and this becomes L sin theta. So instead of r, we'll just put L sin theta to get our answer in terms of L. I hope this question is clear. Now we are going on to our next. Now we are going on to our next question. That is, we are going on some cylindrical type questions. These are, means previously we had that okay. Now in the cylindrical, the conical pendulum or the question that will be happening. Okay, so what they will give us? They will say that this is a string, this is our object, it is moving in a circular path. Okay, this angle is theta, this distance is small r, this is L, and the mass is m. They will give us this information and they will tell to find that the right equation and all they will tell us to do. and we say that this is omega. So first thing is that we have to locate our center. So this is going to be our center. mg will be acting this direction. This is T, and also because it is attached or it is touching this, so normal will be also acting. Okay. So this angle is also equal to theta. This we are saying that this is normal plus tension. Okay, because both are acting, so we have to take the component of both. So T plus N cos theta, and in the center, that is this direction, along the center, to force T plus N sin theta, right? And mg is perpendicular. So we are saying that this force and this force is perpendicular with the center. See, this is the center, this is the center, and this is the mg. Same goes for this. This is the like this. Okay, this is this force, and this is the center. Now with this we can say, what we can say is that we can erase this part and we'll write T plus N cos theta, which is equal to mg, and T plus N sin theta is equal to mr omega squared. Now this is the radius of the circle, but we are asked in the term of L, so we will just replace it by L sin theta, ml sin theta omega squared. So sin theta gets cancelled. We get T plus N is equal to ml omega squared. Why r is equal to L sin theta? Because if we take the component of L, one component will go in this direction, that is L cos theta, and another component will be in this direction, L sin theta. So we can say r is equal to L sin theta. We write it for, so that you don't have any confusion. So this is what we get. Okay, and also from that equation, if we try to simplify this, so T plus N is equal to mg by cos theta. Okay. So now if we want to have the angle in terms of cos theta, okay, if we want to have such that with respect to cos theta and all, so what we can do is we can write as mg by cos theta is equal to ml omega squared. So gets cancelled, omega squared from omega is equal to g by L cos theta's root over. Okay, this is the value of omega we get from these two equations, equation 1, equation 2, right? So these are the values we are getting from this. Now instead of this ball or the object we have considered here, the ball, you can say, what JEE will do, they will say that suppose a man is hanging, okay, man like this is hanging and it is doing circular motion. Man can do circular motion like in this condition, right? So it is having the cylinder is having angular velocity omega and the man is rotating. So from this side if we see the angle is given theta and this is r. Okay, so this is r, this length is given L, and we are told that the man is in rest. Okay, man is in rest, and we are told that there is friction, means mu is not equal to 0. Okay, that means there is friction, some friction is there. So we are told to find the maximum value of friction. Okay, notice the word maximum value. We are told to find, we'll given a language that this is a man which is in a cylindrical shape. So it is the cylinder is having angular velocity and the man is at rest. So it will make a whole paragraph or whole story. It will make a whole story, and it will also not give us the diagram. So we need to interpret the language. We need to draw the diagram, understand the concept. Okay, and then we have to solve the question, which is a time taking, and if we practice it, it will be easy. Like the questions are easy for us. So let's do its solution. So we found its center O. Now we'll make the FBD. This tells us mg, and in this case a normal is acting in this direction, and static friction, because we are told that the man is in rest. Okay, the man is in rest, so static friction is going to act in the direction of as it is holding it. So some friction is acting, that is static. So in this direction mg, normal is acting this way. If this angle is theta, then this angle also becomes theta. Okay, here static friction plus normal is static friction is acting. So as this angle is theta, also we can say that a component of normal will come, that is n cos theta, and a component that is n sin theta along the direction of the center will come in this direction. Okay, so like this you have to interpret the questions, the language from the language. So n cos theta plus static friction, which will be equal to mg, and n sin theta is equal to mr omega squared. So n sin theta is equal to ml sin theta omega squared. Sin theta gets cancelled, is equal to ml omega squared. So this is the value of normal. Now we have to solve it for here. So we are told to find the value of static friction, right? So as we have got the equation, I am erasing this. Now n cos theta plus static friction is equal to mg. We have got the value of n, which is equal to ml omega squared cos theta plus static friction is equal to mg. So we need to find the maximum static friction, that is static friction is equal to mg minus ml omega square cos theta, or in a simplified way, static friction is equal to mg minus l omega square cos theta. So this is the value of static friction. Okay, this is the value of static friction. Okay, you have understood why this is the value of static friction and where it is coming from. So in our option like this it will be given, and also it may be given in some other way, because if the problem is asked by JEE Advanced, already I think it has been asked, it is in the PYQ, you can check it. So already it is asked. So as we know that it is multiple choice and multiple option may be correct in JEE Advanced. So this option is only can be retained in some other form. Okay, so we have to check it and we have to understand. But if we are not getting any other option match, we do not have to waste time, okay, on one question, because in that JEE we need to give one question 1.5 minute to 2 minutes time. We need to give that much time only. Okay, so if we are getting one option correct, we just tick mark and we shall go forward to solve our next question. Okay, this were the cylindrical type of questions. Now some questions are like this. You can say a cone shaped, okay, object is kept here. This is the center. Some angle theta is given. Now we can see that if this is O, mg will be acting, normal will be here. So as this is theta, this angle will be also equal to theta, and this component of normal will be n cos theta, and this will be n sin theta. So what will be the value of n sin theta first? N sin theta will be equal to m r omega square. If we say that the distance or the radius is r, so n sin theta is equal to m r omega square. This is equation 1, and n cos theta is equal to mg. So now they will ask the angle, they will ask omega, they can ask angle. So what people do is they'll find out the ratio. So ratio gives us tan theta, which will be equal to mr omega square by m gets cancelled, g. So tan theta is equal to r omega square by g. So theta becomes tan inverse of r omega square by g. Okay, so the solution for this question becomes this. So this is also a type of question which we may see in exams. Another question which is, you may find that it is similar to this. This is the O, which is the center. It is rotating with omega, and the twist is that this thing this mass is on a horizontal surface. Angle is given theta. Length you can say as L. Okay. The radius of the circle is R. Mass is M. So in this question it is said that this is the bob is in rest, whose mass is M. Okay, and what we need to find here is that we need to find the omega. We need to find the omega for which the contact of the object loses. Okay, so a huge paragraph or a huge description in the language will be given, like a horizontal surface or horizontal plane will be given like that, and on which string will be attached to a wall. That string will be attached to a bob, which is like this. Whole setup will be explained. It will be told that it is in rest, mass is M, and instead of omega they can write the angular velocity for which the contact of the object loses. So find that angular velocity, they can say like this. Okay, whole description they will give and they will tell us to find, but we have to just imagine the situation and solve the question by making its diagram. So I have made a small setup for the imagination purpose. So let me show it. So for this question, I hope this thing is visible to you. So this is this book is a horizontal surface. This is the rod. Okay, now see, I am rotating this rod with omega. Okay, I am rotating this whole surface with omega, or you can say the rod. I am rotating this with omega. See the bob, which is this the bob is in the rest, not bob the object. The object is in rest. See, it is rotating like this. See, I think you can see it is rotating. In this way it is rotating. You can see, so it is rest. But our previous case, which we first did as the problem in conical pendulum, it was like this, that this is a wall in which a string is like this, and it was kept in the initial position like this, and it was rotating like this. Okay, it was rotating by its own. So here the converse, you can say it is happening, that it is in rest and this whole setup is moving. Okay, how it is moving? Because this plate is kept. So now again we will make the FBD. So I am erasing it for now. So first we need to find the center, which is here. MG will be acting downwards, normal will be acting upward. If this angle is theta, then this is also theta. This is the tension in the string, so this is the tension force, and there will be two components of tension force. The first component is in this direction, so we can say that the tension is n cos theta, and the second component is t sine theta. So this is the block, this is the wall, this is n plus t cos theta, t sine theta. Acceleration AC, which is acceleration centripetal, is given along the center. So t sine theta is equal to m small r omega square. If L is given, then better to write in terms of L. So L sine theta omega square. Sine theta gets cancelled. T is equal to ml omega square. So we get the value of tension. And similarly, we can say that mg is also acting downward. N plus t cos theta is equal to mg. So we can put the value of this and we can get the angle. Since we need to find the omega for which the object loses its contact, so the normal will be equal to 0. So we can say that t cos theta equal to mg. And as we have to find the omega, so our omega will be, let us find our omega. So this is mg. Okay, so we need to find the omega. Okay, let us write it as mg by cos theta. Now we are getting two equations, and as we are getting two equations, let's write, we are getting two values of tension, not two different values, same values, but let us put ml omega square is equal to mg by cos theta. So gets cancelled. Omega is equal to g by L cos theta's root over. So this is the value of omega. Directly we could find from here, but we are using that. So I hope this question is clear. Now we are having few questions left. So let us solve those questions. Okay, a basic question which I want you guys to solve in the comments is that if this is a path, okay, and this is the mass, let's consider mass of m, and velocity is acting in this direction and the object reaches here. Okay, and now also velocity is here. So we need to find what we need to find. First, we need to find the equation of circular motion. Secondly, what we need to find is the centripetal acceleration in both cases. Okay, so let me give a small hint, that is, can you see a circle like this? And can you see a circular path? A circular path like this. So can you observe a circular path in like this and circular path like this? So tell me this question in comments, and I will upload its solution in a short, okay, in a shorts video, shorts video. So please tell me its solution in the comments. Okay. Now there is one more good question, that is, we were doing with one string. Now they may say that this is a string which is attached, this is another string which is attached, this is rotating with omega, this whole setup is rotating with omega, this angle is theta, this angle is also theta. Okay, so this is the center O, and now let us make the FPD. So our FPD says the force, that is mg, will act this side. Okay, please don't consider this rod, this is an imaginary line. Okay, so please don't make a normal. Now there are two tensions, as there are two strings, so there will be two tension. So the first tension let's consider is a T1, the second tension is T2. Okay, so now let's take the components of both. So this is the ball mg. So this T2's component, it will have two component, again it will have two component, that is in this direction and in this direction. So first this direction, it will have T2 cos theta, as angle is theta here, and in this direction T2 sin theta. For this string, it will have component in this direction as T1 cos theta and T2 cos theta in this direction, T1 sin theta in this direction. Okay, so now let us write the equation, that is T1 sin theta plus T2 sin theta is equal to mr omega square if the radius of the circle is r. So this is equal to mr omega square. This is the first equation, and the second equation is that T2 cos theta plus mg is equal to T1 sin theta, T1 cos theta. So if we are now told, this question may be asked, I don't know, but this question may be asked, that without calculating, or if none of the values are given, if we are told that which will be greater, which tension will be greater, either the tension 1 or tension 2, which tension in string will be greater. So as we see that both side cos theta is there, so cos theta's value will be a constant. Okay, both values will be same. So but we see that T1 cos theta, this value is equal to some value multiplied plus some value here. So we can say from this thing that T1 must be greater than T2. Okay, so T1 must be greater than, we can say that T1 is greater than T2. We can say it. this is, now we are told to find the angular velocity. So what we will write? We will write omega is equal to t1 sine theta plus t2 sine theta divided by mr root over. This is equal to omega. Okay. So I hope it is clear. This question is clear. Now we have one good question, that is, suppose this is a rod. This is a man which is hanging. And this rod is rotated in omega, okay, in an angular velocity omega, and these two men are rotating, and we are told that they both are in rest. Only what is rotating is this rod. Okay, that question where the bob was at a horizontal plane. So similarly here also the same thing we are seeing. Okay, so now what we want here, that we again want the value of static friction maximum, that we want, and another thing which we want is the minimum value of the coefficient of friction, okay, of static friction which will be denoted by Fs. Okay, so we want the mu minimum here. So let us again imagine this case. So in this case we are seeing that it will say that two men, okay, are two identical man or man of identical mass are hanging like this. Something in the language will be given like this, but we have to understand in a simple form. So we'll take two masses like this and they are in rest, but this rod is moving with an angular velocity. Can you see? Can you see? They are moving in angular velocity. Okay, angular velocity, but the masses are in rest like this. So you have visualized this case. So now what we can do, we'll just write it. We'll solve the question now. So what we can do in this case, so what we'll see that mg force, first of all this is the center, okay, mg force is acting here, mg force is acting here, normal is also acting in this side, normal is also acting here, okay, and the only force which is acting towards the center in this case is the static friction, okay, is the static friction. As just see, this is holding, right, it is, I am holding it, I am in rest, so I have, and this is moving, so it may happen that, see, this is sliding like this sliding, so something is holding it, that is the static friction. So both the case, static friction will be applied. Let me redraw the case. This is the man, this is another man. So static friction is applied. Okay, as they both are identical, we will solve them separately. Okay, first we'll solve for this, then second we'll solve for this, and we'll get the same answer as they both mass are identical. So now so that we can simply solve it, let us solve for 1. Okay, let us solve for 1. So the man is like this, static friction in this direction, this is the center, mg is applied downward, normal is applied upward, so mg is equal to normal, as the motion is like this. So we can say that there is no movement in the y direction. Okay, no movement in the y direction, the motion is moving like this. Let me write it. The motion is like this, the motion is happening like this. Okay, in this, like this, so it is not moving. So we can say that there is a equilibrium in the y direction, that is why mg is equal to normal, and the static friction is equal to mr omega squared if this value of radius of the that circle is r in which they are moving. So we know what is the value of static friction, that is mu into normal. So as the static friction here is maximum, we can say that mu will be normal, minimum here. Okay, into normal is equal to mr omega squared. So mu minimum into mg, as the value of normal here is mg, is equal to mr omega squared. Gets cancelled. We are told to find mu minimum, so mu minimum is equal to r omega squared by g. If we were told to find the omega, omega would be mu minimum g by r's root over is equal to omega. So this would be the value for omega and mu minimum, which we are told to find in the question. Okay, so one last but very important question is left for our today's session. Now again, what is that question? That question is this. This is the center in this case, this is the mass m which is given, the distance is r, this mass is rotating with this circular disc is rotating with omega, this is center O, if we want to, and it is rotating on a horizontal floor, so there must be some friction. Why there will be friction? As we want to see, if you want to see this, see, this is the horizontal floor in this case, and you are seeing that it is touching and whenever it is touching, this mass is touching it, so it is disturbing the circular motion. So in this case, if this is moving on a horizontal plane, then it will definitely disturb. Okay, but here I say the mu is equal to 0, or there is no friction in this case. Okay, so we know that friction is equal to normal in mu into normal. So as mu is 0, friction becomes 0 in this case. And this is like this is the mass M, this is the O, the radius is R, and it is rotating with omega. I hope you have imagined the case from both sides. Okay, this is the side view and this is the top view. So I am writing it top view and this is the side view. Okay, so now we have to solve the question. So what we can see in this case, that first we have given the we are given the center. Now we have to find the FBD. So this is our mg, this is the normal, and again in this case friction is 0. This circular disc is kept on a floor. Suppose imagine the floor is like this. Okay, this is the floor, so it is kept. So the mu is 0 for this floor, but in this case you will say that there is no force which is acting along the center. So in this case, the one and only force, which is friction, is acting, that is static. Why static? Because this mass is in rest, which I forgot to mention. So this mass is in rest and this whole thing is moving. Say for example, this is a book. This is a book, but if this was a circular disc, just imagine it is circular disc. So this is its center and it is rotating like this. Okay, it is rotating with angular velocity and this block is in rest. Okay, now I hope you understood the case, and this block is in rest and the distance from this point to this object is r. I hope you have understood. So the force acting downward is mg, the force acting upward is normal, and there is static friction acting in this side. So if again the question will tell you to find the mu minimum and they will tell to find the static friction friction maximum, so they can tell anything. In this above circular disc, the friction is not equal to 0, but horizontal floor, friction is 0. Okay, it is kept on a horizontal floor and its friction is 0. This is the horizontal floor. Okay, in this case the friction is 0. So now let us write the circular motion. So they will again say find the static friction, find the mu minimum. They can say anything. Okay, you need to just play with the question. Just write the circular motion equation and you can find anything whatever you want. You want normal, you want mg, you want static friction, you want omega, you want omega squared, you want velocity. You can find anything if you write the circular motion. So main thing is you have to write the circular motion. So first two steps you have followed. That first two steps you have marked the center. First step you have done. Second step what you have done is you have found the FBD. Now third step which we are going to do is write the circular motion. So the circular motion equation. So Fs is equal to mr omega square. Here the distance is smaller, so I'm writing smaller. Okay, and as see, just whenever there is a problem in physics or question, reread the question and try to visualize the case in your mind, because every time you are not getting objects around you, so try to visualize, because if you visualize, things will automatically come to your mind and you will solve the problem. So see, it is moving like this. Okay, a circular disc is moving in this way. So it is moving in the you can say that it is moving in this particular plane. But if we say that this direction is the y direction, so is it moving upward or downward? Is it moving so? Is it moving in this plane? In this axis? In this axis, is it moving? No, it is not moving. So as it is not moving, so we can say that in this direction, above direction and downward direction, specifically I am saying above direction and downward direction, because if I say that it is in y axis, so you can change the axis, okay, as per your, if you're looking so different from different perspective, you can change the axis. But if I say that downward and upward, so it will be more clearer to you. So normal is equal to mg, we can say. Okay, now I hope you know that why I am saying normal is equal to mg, because why I am writing it in this question, because this is the last question of a session. So why this is? Because it's in equilibrium in this direction. Okay, so you understand it. Now as we are told to find the maximum value of static friction, so this will be our maximum value for static friction. Okay, this will be our maximum value for static friction. Now if we are told to find the minimum value of mu, or we are simply told to find the value of mu, so mu is equal to friction is equal to, we can say, mu into normal, so which is equal to mr omega square. Mu minimum is into mg is equal to mr omega square. Putting the value of normal, this gets cancelled. Again, mu minimum is equal to r omega square by g. See, the answers are coming similar. We are doing different questions, but we are finding same answers for these things. Okay, so questions, what are questions? They are the different presentations, different cases, different presentations of same concept. The same concept is applied. This one thing only we studied in the lecture. We just recapped, we visualized, and what we studied is how to write the equation of circular motion. Rest all is same. See, same answer. Again, I will find omega value. Omega will be mu into g by r into r. See, same value. Okay, so some people, what they do, they memorize these values and they go to exam. Yes, it is beneficial, but I don't memorize any of this. Okay, and even I didn't know. I am just solving and the answers are coming, so I am telling you. So are you saying that physics is so easy? It is not difficult when it is visualized. So what is difficult then? Why people, you may see that when we are studying in class 7, 8, 9, we are scoring good marks in physics. But when we are going class 11, 12, then we see that our seniors are scoring very less marks. Okay, why this happens, that some very good students in physics class 7, 8, 9, 10 are scoring less marks in physics. Why? It is because that their mathematics is very poor. Okay, like these calculations are coming, so this root over, and so you're seeing that we are told to find omega. So what is difficult then? Difficult is not physics. Physics is very easy. That only thing which is difficult is these calculations, the calculation inside root. So there will be a value like 1.357. Okay, maybe the value inside this root come like this, and you're told to find the under root of this. Okay, so these things are difficult. That's why people score in less marks. So if we master those things, no one can beat us in physics, especially in JEE. And this is only which is required. So for today we are done. Okay, I have attached my notes which I have made myself in the description box, and I will also pin it in the chat section or in the comment box. And I have also attached some 4 to 5 question language cracking problem. If you crack the language, if you understand the language, then you can easily solve the questions. As you are saying that diagram and visualization of question is very important. If you do those things, you will crack JEE. So that's all from my side. Thank you.